Imagine being able to look like anybody in the world whenever you wanted to. And no, I don't mean with an obvious fake party mask. I'm talking about the hyper-realistic skin suits that are taking Japan by storm. Recreating these human-like masks requires several hours of painstaking silicone mold sculpting. Artists often have to hand paint these masks and add detailing to match the muse's skin, tone, texture, and features, right down to freckles and blemishes. The resulting skin suits are almost indistinguishable from real human skin, and unless you get really close, you may never be able to tell that the person sitting next to you is someone else. Who knows, they could even be you. Tokyo-based mask maker and store owner Kamenya Mote is offering people money to buy the rights to their faces. For a $380 payment, the company can reproduce hyper-realistic replicas of your face and sell them. And if your mask is really popular, you could even earn a percentage from the profits as well. On the other hand, if you'd prefer to be a collector like the faceless men from Game of Thrones, or fool your friends into thinking you've aged like grandpa, you could order a customized silicone face online. I mean, that would be a great Halloween prank. But while this technology signals a significant breakthrough in our ability to mimic and recreate human-like features, there's understandably cause for public concern. For one thing, not everyone has harmless intentions like pulling a prank or using these hyper-realistic faces to create better movies. Once these masks become widespread, people could also use them to successfully commit crimes while framing someone else. Forget about identifying deepfakes through a screen. How would we be able to distinguish between real-life doppelgangers? In 2023, the world buzzed with fascination when influential personas like Elon Musk, Jeff Bezos, and Mark Zuckerberg showed up at an NFT conference in New York. When Landon Meyer, the maker of these masks, revealed that they were actors wearing hyper-realistic skin suits, the audience was astonished. Meyer also told Insider that each mask costs $20,000 and takes a month on average to make. With this technology, we may have to throw away the adage that seeing is believing when our eyes could be wrong. Across the Pacific Ocean, American artists and researchers are also exploring the possibilities of using silicone mold to create not just faces, but full body suits. On platforms like Amazon, you can now buy full-size silicone body suits that look like hyper-realistic humans. And considering these suits are made to offer users maximum comfort and flexibility, they often fit like a glove. They also come in a diverse range of body shapes and textures, so you could look as built as Dwayne Johnson or turn heads like Marilyn Monroe. But beyond cosplaying your favorite characters and celebrities, these silicone bodysuits also have medical and therapeutic applications. Because of the comfort they provide, they're one of the most common materials for prosthetic limbs. They're also easily customizable, which makes for a better fit without the irritation other prosthetic materials often come with. Still, as suits get more realistic, it's only a matter of time before they become a widespread cosmetic accessory. After all, why take the risk of undergoing risky procedures or sweating it out in the gym all day when you could throw on your dream body as easily as you wear a coat? Down the line, companies could even start designing humanoid robots with silicone body suits to give them a more human-like appearance. The soft and flexible material could even make it possible to program these bots with a sense of touch, making them more delicate and less intimidating. As a result, human-AI interactions could become more natural when you talk to a robot that looks just like a real person. If you think making inanimate objects look human is crazy, wait till you hear about this next invention. Back in Japan, scientists recently made an astonishing breakthrough in September 2024 when they grafted living human skin tissues onto a smiling robot. Led by Professor Shoji Takeuchi at the University of Tokyo's Biohybrid Systems Laboratory, the system was able to perfectly transfer living tissue from a petri dish to a humanoid bot without bunching it up or tearing it in the process. Sounds like a real Frankenstein project. This experiment is especially outstanding when you consider that Takeuchi and his team have been working on this technology for years, but had always managed to come up short with the skin getting damaged during the transplant. So how exactly did they pull it off this time? Well, the team had to take a closer look at human anatomy and try to replicate that. Under normal circumstances, your skin stays attached to your face because of a complex system of connective tissues, mostly collagen and elastin, which anchors it to the underlying muscles and bones. These proteins make the skin flexible enough to move when we laugh, frown, or show other expressions, and despite stretching in multiple ways, it's tough enough not to tear. With that in mind, the researchers had to improvise with a special collagen gel to make the fake skin tissue stick on, and specially made V-shaped perforations that mimicked ligaments and could anchor the skin to the underlying metal. The result was a pink, fleshy blob with glass eyes that looked more like the animated sidekick Morph from the movie Treasure Planet than an actual human being. However, the team was able to successfully manipulate it to mimic a smile without tearing the skin, which is still quite a remarkable feat. In future projects, Takeuchi's team hopes to recreate more complex skin that incorporates additional structures like muscles, sweat glands, pores, blood vessels, and even nerves. In other words, even if a humanoid robot with this human-like skin were to sustain a bruise or tear, its skin would have the necessary cells and structures to fix itself, just like you. But why scratch the mere surface when you could go so much deeper? Scientists at the FDA are currently working on technology to improve drug research and development by recreating human organs on chips. Besides helping researchers achieve more accurate results on drug efficacy and toxicity, this groundbreaking tech could also benefit animals. With better and more accurate ways of testing experimental drugs on human cells, there's a lower need for animal testing, which could spare millions of animals worldwide subjected to clinical trials. Thus, organs on chips offer us a more humane and perhaps even efficient way to make progress in education and research without harming animals. However, considering this technology is still new, the materials and equipment to produce and maintain it are quite expensive. As you might expect, recreating human organs on a microchip is a complex process that requires very specific conditions. For starters, scientists have to make tiny microfluidic channels that successfully mimic blood vessels and other fluid pathways in your body. After that, they harvest living human cells and culture them in this simulated 3D environment. But it doesn't stop there. To get the most out of the experiment, researchers have to recreate the mechanical forces in the organ. In other words, it's not enough to make an environment similar to a human lung and put it in a glass slide. You also have to apply the same stretching and compression forces lung cells deal with if you want real-time and accurate results. Breakthroughs in artificial intelligence are also making waves in genetic engineering. Like, who needs to test new cancer drugs when you can use AI to edit and erase the parts of your DNA that predispose you to certain medical conditions? Thanks to complex tools like CRISPR-Cas9, we're on the verge of being able to code DNA sequences ourselves without leaving it to fate. While there's limited information on human testing, scientists have begun testing their theories on bacteria with significant success. For instance, in 2022, University of North Texas professor Calvin Hennard announced that he and his team were working on engineering bacteria that could eat greenhouse gases. In other words, rather than causing mold or breaking down animals, Dr. Hennard and other researchers at his lab, the Biodiscovery Institute, were able to make what they call methantrophic bacteria that consume carbon dioxide. There are even talks of producing more gene-altered bacteria that can convert methane gas to more useful products like bioplastics and biofuels. That means we could effectively use AI to reverse climate change. But the implications of this technology aren't limited to just bacteria and lower life forms. We could turn gene editing inwards and use it to create genetically perfect humans. Scientists are currently working on ways to modify our own DNA, giving us the power to alter our physical traits. However, gene editing goes beyond changing superficial characteristics like how you look or how tall you are. It could also potentially help us eliminate hereditary diseases like HIV, sickle cell, and even some cancers. And no, we're not referring to what we could potentially do someday. Gene editing is possible right now, but it's still undergoing extensive clinical testing. It's a complex process that involves using AI algorithms to pinpoint specific DNA sequences, designing a new guide that fits perfectly with the gene we don't want to express, and cutting it off with the Cas9 enzyme. That's why it's so important to get it right, because the last thing you want to do is snip off parts of your DNA essential to life. But once we master these AI tools, we'll be able to genetically modify our DNA at will, adding and removing traits to our liking, just like a Build-A-Bot. Another way researchers are looking to curb diseases and make advancements in healthcare is by introducing miniature robots into the human body that can perform operations through minimally invasive techniques. Chinese researchers have been working on producing tiny robots that can travel through your bloodstream under magnetic control and perform medical interventions. In other words, if you had a life-threatening condition like an aneurysm that typically necessitates surgery, rather than opening you up, doctors could inject these magnetic microbots into your bloodstream where they can deliver clot-promoting agents that seal off the aneurysm. But there's more. These microbots could also make cancer treatments a lot more effective by delivering chemotherapy drugs directly to tumor cells without affecting healthy tissue. Besides making healthcare more targeted, the best part about these miniature bots is that they don't require you to undergo general anesthesia for an operation. You could pass these tiny buggers through a small incision in the skin, or even intravenously, drastically reducing the need for traditional surgeries and all their complications. Going under the knife for an operation would become a last resort for more complicated conditions like an organ transplant or a C-section. And while these microbots are still in the development stage, they'll likely receive approval for clinical use in a couple of years, which will revolutionize healthcare as we know it. Would you trust one of these magnetic microbots to save your life? Well, how quickly these microbots start rolling out depends heavily on the ongoing battle for dominance in the semiconductors market between America and chip. While these magnetic microbots don't depend on semiconductors directly because of their microscopic size, the technology that controls them does. Most researchers use semiconductor technology like CMOs to give these tiny robots microelectronic circuits, which sort of acts like their brains, giving them a sense of their environment and allowing them to respond to external stimuli. Considering how fundamental semiconductors are to producing this and other artificial intelligence technology, the US sought to establish a monopoly by banning the exports of manufacturing materials to one of their biggest economic rivals, China. But rather than slow down the Chinese, this policy seems to backfire when China responded by pouring more investments into domestic semiconductor production with notable success. To rub salt into the wound, they retaliated against the US policy with another one of their own, banning chipmakers like Micron for selling their products within China. Before the US imposed its ban, NVIDIA's H100 was the golden child of AI accelerators for its high performance and efficiency. Originally starting as a company that produces graphics cards for gamers, NVIDIA is now a tech giant forming the backbone of AI companies like Tesla, Amazon, Intel, and Google. But as the rivalry between the US and China intensifies, it's obvious that NVIDIA has a lot of work to do to retain its #1 spot and uncontested market domination. Right now, China's frontrunner to replace the H100 is still slightly behind NVIDIA in terms of performance and energy efficiency, but the Huawei Ascend 910 is still an impressive piece of AI hardware that could potentially dominate the marketplace. Despite the US attempts to stifle China's chip-making technology, the processor still boasts an impressive high-speed interconnectivity between its components, making data transfer more efficient. It's no surprise that Huawei's Exynos 910 is their flagship chip, powering integral infrastructure like their data centers and cloud services, and could potentially work in self-driving vehicles. It also helps that the processor uses a unique DaVinci architecture that is optimized for AI workloads, especially deep learning. As impressive as that is, it still comes up short compared to NVIDIA's H100, which uses transformer engines that accelerate their AI models like GPT-4. Another American chip startup making waves recently is Grok. Their chips are much more energy efficient than typical GPUs, which reduces their operating costs, making them cheaper in the long run. Their high performance features also make it easier to complete AI inference tasks, especially when running large language models. We could even apply the same technology to more complex technologies, like autonomous driving and financial trading, where their low latency results can make our world more efficient. So what do you think about America's and China's rivalry over semiconductors and the possibility of using complex technology to recreate skins and organs? Are these inventions a major win for healthcare, or are we trudging through dangerous waters? Let me know what you think in the comment section below. Don't forget to hit the like button and subscribe for more updates like these.